Well, today we're going to go ahead and take a look at linear programming. For the most part, you're going to be graphing systems of inequalities just like we did yesterday. But you need to find those corner points like we did on some of the problems yesterday, but you have to plug those corner points into a separate function. Oops, like this one here. They're trying to find the max or the min. So here on the left, we have our system of inequalities that you're given. The purple is just a vertical line, and you want x, which goes left and right. You want x to be less than that, so you need to be everything to the left of that vertical line. So we have our vertical line right here at x being 5, and we got to be shading to the left. Once again, when you're looking at your linear programming for solving a system of inequalities, it's where all three or however many inequalities you have overlap. Looking at the red one, y is less than or equal to 4. That's a horizontal line, always at a height of 4 for your y's. We want to be less than that, and remember y goes up and down, so you're going to shade below that. So we need to be shading to the left of the purple. We need to be shading below the red. Then we can go ahead and take a look at this blue one. Well, I'm going to get y by itself. So I can go ahead and get y by itself, and I can use my slope and y-intercept. If I do that, y-intercept of 2, slope of -1, I get the blue line. I have y being greater than that, so I need to shade above. So I got to be above the blue, left of the purple, and below the red, so that's this triangle shape here. Now, a second way you could do the blue, which is going to sometimes be very, very helpful, is to find your intercepts. You let your x be 0, plug in 0 for x, find y, and we get 2. And then you want to find your other intercept, and that's when a y is 0. So you take 0 for y, plug it in, and you get x to be 2. So the first one, you're over 2, or over 0 up 2, that's this point here. Here, this one, you're over 2 up 0, that's this point here. These 2 points determine your line. You could draw those in. It's not as helpful on this one, but on most of your problems, that will be helpful. So now you want to find your corner points. So once again, if you do an accurate graph, you can easily find your corner points as we have indicated over here. So I put my x and my y, my x and my y, my x and a y. Now I got to plug those into my function right here that I'm trying to maximize and minimize. So I took my 3x minus 2, put it right here. Take my -2, plug it in for my x. Minus, take my 4, plug it in for my y. And I get -14. Do the same thing for my next point. Take my 5, plug it in for my x. Take my -3, plug it in for my y. Work that out, I get 21. And I want to do that for my third point. Take my 5, plug it in for my x. Take my 4, plug it in for my y. Work that out. Now I'm looking for my maximum, which would be the biggest of these, which I can see is -21. And I'm looking for the minimum, which would be the smallest of these, which I can see is the -14. So I now have my max of 21, my min of 14 for this particular problem. Sometimes you're going to be looking for your output values, which is the max and the min. Sometimes you'll be looking for what gives you the max, which would be this point of 3 comma or 5 comma -3, or what would give you the min, which would be -2 comma 4. So make sure you're reading the question careful to see if you're actually looking for the output like these over here, or for what gives you the output, which would be your points. In general, in trying to solve linear programming problems, you're going to have to define your variables because you're going to be reading a problem. You're going to have to make up a system of inequalities from reading the problem. So you have to define your variables, write your system of inequalities, graph it, find the corner points, and then plug it into your max or minimize function, and then write down your answers. So for this particular problem, we'll go ahead and look at it. Pause the video, read through it, Probably read through it a couple of times. So for this problem, we're looking for mowing and pruning that will give us the maximum income. So I'm going to let M be for mowing my lawns, P for pruning my lawns. Those are going to be my two variables. Now we're looking at number of jobs here. So I know I can't have a negative number of jobs. So my mowing has to be greater than or equal to 0 because I can't have a negative number of jobs. My P for pruning would also have to be greater than or equal to 0 because I cannot have a negative number of jobs. Often you're going to have your variables being greater than or equal to 0. Once in a while there might be a problem where that doesn't work, but most of the time you're going to have those. Now in this particular case we have 4 inequalities that we're going to have to write. We already have 2 of them. Now another one is, for the most part, when you're coming up with your other inequalities, you're going to be looking for what restrictions are showing up in your problem. Well, one of the restrictions is highlighted up here in gray. No more than 2 pruning jobs per day. Oh, so no more means 2 is the max, so I could be 2 or less because you have no more than 2 pruning jobs a day. If you have another restriction, that's going to be another inequality. And up here, highlighted in purplish blue, it's supposed to be blue, but it's somewhat purplish blue. Sorry about that. But the blue, it says a maximum of 9 hours a day. So 9 hours a day. Now, some of your hours come from the mowing the jobs, which is 1 per day, and pruning, which is 3 hours. So we're going to have 1 times the hours plus it's 3 for each pruning job. So that's the 3P. Now, we were told a maximum of 9 hours a day. So the mowing plus the pruning cannot be more than 9. So it's got to be less than or equal to 9. Now, we could go ahead and get one of your variables by themselves. And then we could go ahead and use your slope and your y-intercept. So if we go ahead and make our graph, we could have our mowing hours here. We could have our pruning hours here. We know that P and M being greater than or equal to 0, that's going to be where they're both positive, which is the first quadrant. Then we could use our slope and y-intercept, start at a height of 3, then our slope is down 1 over 3, down 1 over 3. This one here, your P is less than or equal to 2. We could have that. That's height of 2, below that, so we have this trapezoid shape. Now, a lot of these problems, using your slope and your y-intercept is not going to necessarily be the best way to do it. It's going to be better to make a t-chart and use your intercepts. Now, notice I have M on the x-axis, so I'm putting that first, because normally your first column is your x. So I plug in 0 for M. If M is 0, plug that in, solve it, and I get 3 for P. Then I want to, and that's this point here. Then I want to find my other intercept. So I want to plug in 0 for P. If I plug in 0 here, times 3 is 0, I find M and I get 9. That would be this point here. It's often nice to do the intercept for this table because they're going to often be your corner points where you touch your axes, because that's often where your shading will be. So we knew this point here. This point here was easy to find. This point out here in green is really the intersection of, oops, I got to get rid of one thing here. What we're looking for that green point right here is the intersection of this and this. So you could solve that system of inequalities or equations with P equaling 2 and M plus 3P equaling 9. Because we're trying to figure out where the lines cross, and that's the equal to part. So we could take this P being 2, and we could substitute it in right there. So you can use substitution elimination matrices to find all these other points. So once you have all your points, you want to plug them into your what you're trying to maximize or minimize. Up here, as you look, we're trying to maximize our income. So we get some income from mowing our lawns, and we get some income from pruning our shrubbery. So we get $40 for each lawn. So it's 40 times M, and that M should be italicized, plus, and it's going to be 120 for each pruning job, and that P should be italicized also, because variables are italicized. So we have our pruning job right here. We plug in our points, write our points down, and it's not liking that, so just a second here. Our first point in orange, our next point right here, our next point right here, and our next point right here. We're only looking at the corner points of your shaded region. We want to take each one of those quarter points of the shaded region and plug them into your income. Plug in 0 and 0. Well, if you do no work, no pruning jobs, no mowing lawns, of course you're not going to make money. And then we could plug in M being 0 and P being 2. Notice I have this M first because I had M here on the x-axis. I have P being second, which is what I had on my y-axis. Plug in 0 for M, 2 for P, and I get 120. Plug in 3 for M, 2 for P, I get 360. Plug in 9 for M, 0 for P, and I get 360. So now we're trying to find maximum income. Now, are we actually looking for the maximum income, or what gives us the maximum income? In this case, it's looking for the combination of mowing and pruning jobs that produces the max. So some problems, if it just said find the maximum income, that would be the biggest one that you get out over here, which would be $360, and that happens twice. Now, if you're looking for the max, it would be one of these two right here. But we're looking for what combination gives us the max. So we actually have two different options. We could either use this option, or we could use this option here. Most of the time, you only have one answer. So we could have either 3 mowing jobs and 2 pruning jobs, or you could just have 9 mowing jobs. Either way, it would work to give you your maximum income.